Okay, 7.4, hypothesis testing for proportions. Okay, so remember that means it's going to be binomial. So for instance, yes, no, 60% say yes, 40% say no. That means P would be 0.6 for 60%, Q would be 0.4 for 40%, and don't forget, you've done this before, okay, you have to check if these things are true, okay, to see if you can do this test. Now the steps are going to be the same. Do your statements, what's alpha, determine your critical value, that's inverse norm, okay? Then your rejection region, is it on the left, is it on the right, is it on both ends? Okay, two-tail. Okay, find the standardized test statistic, that's using your calc. Okay, and then you make your decision whether to reject or not reject the null hypothesis, and then interpret the decision. Let's just go through quickly an example. This is a two-tail one. So, researcher claims that 25% of college graduates, okay, et cetera, okay, so there's where you use the 25%. There's your null, there's your alternative, there's your claim, right? Not equal, so it's two-tail, so there's two-tail. Okay, now, you take a sample of 200 college graduates. 21% say yes. That's your P, 0.21. There's your alpha. You got to split that in half, right? Because it's two-tail. Okay. So now, what do you do next? Well, you need to find Z. Okay. But remember, to find Z, we use inverse norm. Okay. Here, you'd have to use 0.05, right? So each end. This is 0.05 here, 0.05 here, because alpha is 0.10. Okay, that gives you these two z-scores. Okay, then you do your test. It's a one proportion z test. Everything's z. That's why it's inverse norm. Okay, there's your p. That's what they claim, right? And then 42 is 21% of 200. Sample size. This cannot be a decimal. Remember that. You've run into this before. It's not equal, so it's two-tailed. Here's what you get. Okay. That is between, right? It's not in the rejection regions in the left or the right tail. So you fail to reject the null hypothesis.